We have a number of lectures that we break down into 3 talks. There will be myself just to give an introduction to the project, an overview of what the project is. Dr. Monica Mateo Garcia will go through the technologies that we've installed and the processes and the stakeholder engagement processes that we went through throughout the project. Mr. Kasim Karatella, who is part of the coordinating organization of the project, will also discuss some of the processes and protocols for selecting building selection and technology selection for the project. And then we would like to end up with a roundtable discussion at the end between 4 and 4:30, hopefully. And we will encourage you, if you have any questions, to engage us at that time. And we would be interested in sharing further information that we don't have today. We will be very interested in sharing those information with yourselves in the future as we articulate the results of the project. And then we will have some drinks and networking at the end, so don't rush away. So I think just to set the scene for why the work that we are doing is very important. We know that energy consumption in the built environment accounts for about 40% of total energy consumption and about 50% of carbon emission as a result. So that's significant. If we are to reduce the impact that the built environment have on our planet, then we have to basically consider improving these buildings to a higher performance standard. At this point in time, the problem that we have, the challenge that we're facing, is a significant proportion of these buildings were constructed, a long time ago, and the energy efficiency standard wasn't very strong at the time. Therefore, a lot of them basically are coming to the end of their useful life. And when I say useful life here, I'm referring to when the building cannot meet the expected energy and environmental performance standards expected today, basically. So if we said that we're going to replace all the existing buildings with new ones, that is not feasible for a number of reasons. Basically, there will be significant cost associated with constructing new buildings, and there will be significant environmental impact. Somebody asked me the question earlier, what is the environmental impact of the PCM? Basically, what that means is that what is the impact of the materials that we use to construct our built environment? If we demolish all of our buildings, then we have to use new materials to construct new buildings. And there will be a lot of environmental impact, embodied energy of those building materials and components built into that process. So that is not the best strategy to move forward. Therefore, we have to refurbish our existing buildings. We have to improve the performance standards. There are a number of benefits to energy efficiency retrofit or improving the performance of existing buildings. There are economic benefits, such as the cost savings and economic stimulus. So you save a lot of cost compared to constructing new buildings. And obviously, the small and medium-sized companies are the companies that normally get involved in retrofitting existing buildings. So there is some economic stimulus associated with that. Not only small companies, but big companies as well. Improvement in property value. The value of your property will increase without the associated cost of constructing new buildings. And obviously the impact on public finances. If Coventry University decide, okay, we want to replace all the existing buildings, that will be significant cost implication. So if that is extended to the NHS and other public organizations, that will be a major issue for public finances in the UK and other parts of the world as well. There are societal benefits, the improvement in comfort and health and productivity of building users. As you improve the environmental conditions within the built environment, as we were trying to do with the phase change materials, you improve productivity as a result of the building users, the health of the building users as well, as the quality of the built environment improves. And then we have the environmental benefits, reduced air pollution and carbon savings as a result, which we know there is abundant evidence to show that those are the causes of some of the climate change that we are experiencing at the moment. And I'm sure each and every one of us has experienced some manifestations of climate change over the last couple of years, whether it's drought, whether it's flooding, or perhaps significant increase in global temperatures. And then we have the energy systems benefit, which we have to think about as well. The energy security, avoiding need for new generation capacity, that is very important, especially when we are talking about summer overheating in buildings. Because what will happen then is that we're going to have peak demand for electricity during the summer months. And that is it's going to be a major problem for the UK, for example, whose energy consumption dynamic is maybe more heating energy consumption and much less cooling energy demand. If that happens, then we have to start considering new electricity generation capacity across the country, which is the last thing the UK wants to do in terms of cost and in terms of environmental impact as well. Okay? It's not straightforward. Retrofitting existing building is a challenge, and we have to recognize those challenges and find solutions to those challenges. There is the issue of performance gap. This is not limited to only retrofitting of existing buildings. It is a phenomenon that the industry is dealing with, where the building is performing worse than the design performance, and majority of the buildings are performing worse than their design performance. If you consider the energy performance certificate, which is the predicted energy consumption of the building, and the display energy certificate, which is the operational energy consumption of the building, there is huge mismatch. And this is not only limited to retrofitting of existing building, but much more of a challenge for retrofitted building, because you don't have enough control over the sort of action that you can take to improve the performance of all the components of the building. And then we have the other issue, which is core issue in terms of retrofit, which is the unintended consequences of building energy efficiency improvement. We improve the energy performance of the building fabric and obviously the building air tightness and so on, and without any consideration for ventilation. And as a result, the health of the building occupants and the building owners and the building fabric is compromised. Therefore, we have to think about the holistic approach to building energy efficiency improvement. When we are improving energy efficiency of the building fabric and air tightness and so on, we have to start considering the comfort of the users as well, the ventilation and indoor air quality in the spaces. The lack of robust tools for optimizing conflicting factors that I just highlighted. You want to improve energy, but you want to improve comfort within the building. You want to improve air quality as well. We don't have any robust tools and approaches for optimizing these conflicting factors. Cost as well as part of the equation, comfort, energy consumption, and environmental performance, which is part of what the project is trying to achieve. We require an inclusive approach, considering the building fabric systems and user behavior as well. Users are a core component of how the building will perform. Are we taking the views of the users into account when we are designing our solutions? It's a big question mark. Most of the time, perhaps, engineers and construction professionals design buildings without effective stakeholder engagement. And there is significant evidence that in order to achieve the socio-economic and environmental benefit of building energy efficiency improvement, any building energy efficiency improvement, stakeholder engagement has to be core part of that process and not a process that happens after the event. And in order to avoid some of these performance gap and unintended consequences, we also need a systematic process of pre- and post-intervention performance evaluation. We need to evaluate the performance of the building before any intervention and the performance of the building after any intervention. We learn from those processes and we improve our energy efficiency improvements in the future. So we want to make sure that we deliver the appropriate comfort and energy consumption. It's not the design, but actually are we delivering in reality? So we need to monitor before and monitor after. I will give a couple of minutes description of the RESSEEPE project, which is retrofitting solution for the retrofitting solution and services for the enhancement of energy efficiency in public buildings. And the project is basically a 4-year project. We are at the tail end of it at the moment. We have 25 partners from across the European Union. 25 different partners from 10 different countries from across Europe. That obviously suggests that there is a significant amount of diversity in the project. The category of partners include the demo site, the research institution, industrial partners who produce some of the materials that we showed you earlier, social housing organizations, and different disciplines, and engineering, energy efficiency, and building construction, and so on. The core aim of the project is to improve building energy efficiency through retrofit, and to set up a diagnosis methodology for an integrated renovation of public buildings and district levels. So we want to be able to diagnose the current performance of the buildings and then propose solutions that suit that particular building. In particular, when we showed you earlier the phase change materials, that was done based on the understanding of the challenges that is being faced within the building itself by the earlier stakeholder engagement and the diagnosis that has been developed in the project. Development of a systematic view of selection of the most empowering retrofit mix. I think one of the challenges that we face is what mix of technologies can we use? Should we just focus on the fabric? If we do that, as I mentioned earlier, then we have the unintended consequences that I was talking about. So what is the right mix of retrofitting technology that we can use? How can we adapt, demonstrate, and validate these technologies on real buildings and monitor the performance of these technologies? As we mentioned before, technology providers can tell you how fantastic their product is, but really, in reality, the performance of these technologies doesn't match up to those that had been publicized by the various organizations. In figures, basically, we're trying to achieve a 50% energy saving in the different demo sites. That was the initial project intent. Energy consumption reduction of about 66 kilowatt hour per meter squared per year. And carbon emission reduction of about 48.15 kilogram per meter squared per year. And a rehabilitation cost of 19% of investment costs associated with new construction. The project is divided into 8 different work packages. The first work package is basically the coordination and management work package, and then we have the diagnosis methodology, the development of a diagnosis methodology, which Mr. Kasim will later on talk about. Then we have the work package 3, which is technologies for retrofitting solutions, basically the identification and development of some of these technologies, and the development of design methodology for energy efficient building and district renovation. And then we have the other work packages that are more exploitation, work package 6, which is managing the demonstration activity, because we have about 6 different demo sites across the European Union. Therefore, there is a coordination issue there, demonstration of public buildings and district level. Then we have the exploitation work packages, the dissemination and communication and exploitation work packages that makes sure that the results of the project are being disseminated to key stakeholders within the community. We have 5 demo sites, as I just mentioned a moment ago, across 3 different countries. We have 2 demo sites here in Coventry, which we pointed out to you earlier, and the 2 hospitals in Barcelona in Spain, and 1 school building in Skellefteå in the north of Sweden. So basically covering the range of climatic condition across Europe. The warm condition, the very cold condition, and the more milder UK. And Coventry University, basically a total of about 13,000 meters squared area, energy consumption of the buildings of about 175 kilowatt hour per meter squared per year. So this is basically some of the information, the energy consumption information about the various buildings that we are renovating, and some of the selection of technologies that we integrated within the various buildings. Just going to go. Monica will talk a little bit more about the selection of these technologies, but I thought that an overview of these technologies is important in this presentation. We basically categorize them into envelope technologies, building more passive PCM cooling and storage, and the renewable energy technologies for the John Laing building. And then we have, for the Richard Crossman building, we have the roof improvement, the window changes that we made, and a new building energy management system, the LED lighting, and the solar photovoltaic system. Again, a little bit more discussion of that in the subsequent presentations. I think, just to conclude, one of the, again, issues or learning from this project is the complexity of when you have so many different partners, and I'm sure this discussion is happening within the industry, is the issue of information and communication, information sharing and communication. And this project is very, very complex in that we have several partners and we have to share information with all of them. Coventry University managed the dissemination and communication platform, which is what is being generated within the project, how this information is being shared internally within the project, and also the engagement with the various stakeholders. And that brings us to the discussion of building information modeling and so on. How could we have maybe used some of these building information modeling processes and protocols within the project? That could have really provided significant improvement in efficiency within this project. And this is definitely something we're learning and that we are going to do in subsequent projects. And I think that's me. There's more information on the project, some useful links where you can get further information. And we will share all these slides, we will share them with all the participants. So don't worry if you can't get a grips with the links.